Hey everyone, welcome back to the lab. In this video, we're going to be going over how to run your SvelteKit app on Node using a Docker container. So to do this, we're going to be going over three things. First, the requirements that you're going to have to actually follow this tutorial successfully. The second one is going into the details about how you can actually containerize your SvelteKit app and serve it in Node. And lastly, we're going to be going over some FAQs. So a lot of things that I've seen people have questions about and some important decisions and trade-offs that you need to think about when you decide exactly how you want to containerize your app. So first, let's start off with some requirements. So the first thing that you're going to need is an actual SvelteKit app, and specifically a SvelteKit app that has the Node adapter. Now, this is outside the scope of this tutorial, but basically SvelteKit is built to be agnostic to platform, and the way it does that is by allowing you to configure adapters, which allow you to build your SvelteKit app towards the ability to run on a specific platform. In this case, we're trying to run on Node, and that's what this whole tutorial is about. So you need the Node adapter so it can actually build and run on Node. So once you have that SvelteKit app, the next thing you'll need installed is Docker. Because we are building a container with Docker and running our container with Docker, you need Docker installed on whatever machine you're using in order for this to actually run. So now, assuming you have those, we can go forward into the tutorial. Okay, so let's go into actually how we containerize SvelteKit and build and run it with Node. So an overview of how this is going to work is first we're going to have a step for building. And so what this is going to do is it's going to build SvelteKit using Vite, which comes along with SvelteKit. And because we have that Node adapter, it's going to build it and output it in such a way that it could be run with Node. Now, building takes a lot of different resources. There's a lot of things that we only need for building, but we don't actually need for running. And so that's why we have the second run stage. So it's basically going to pull the artifacts that we created from the build stage that we actually need to run, put it all together, and then it's going to actually run it and serve it with Node. Theoretically, this image that we create is going to be a lot more optimized, both in size and theoretically performance than if we just use the build one. And I'll show you a little bit of stats later on what I've seen in my own projects. Okay, so with that understanding of how this is actually going to work, let's actually go into some code. So here on the screen, I have two things. First is your Dockerfile, which is going to tell Docker how to actually build and run this container. And the next one is package.json, where I've just pulled out the things that are most important to this tutorial so you can understand how it all fits together. So let's start with the Dockerfile, and you should see that there are two layers. The first is that build layer, and the second is the run layer, and those correspond directly with the stages I told you about earlier. And so in this build layer, what we're doing is we're pulling down just a clean version of the Node image. We're creating a new work directory. We're copying in our package.json, which lists all of the dependencies and everything we need to build our app. Then we're going to just quickly remove any Node modules or build folders that might exist. We don't want those because it might actually create non-determinism if there's some stale stuff. Then we're going to copy in our resources. So the resources that we're trying to copy in are like our actual code and stuff. We're going to run npm install, and this is going to install both our regular dependencies and our dev dependencies because we are trying to actually build this. And then we're going to run build. And if we look at what build does in our package.json, it's just using Vite to actually build. Now, by default, this is going to come out to this /build folder. This is just how Vite's configured by default. You can configure it to something else, but I think /build is a reasonable folder to go to, and so I haven't configured it to anything else. So theoretically, after this stage, we've got all the things, our entire app is built and exported into like a simple package in that build folder. Now what we're going to do is create a new clean image called run, where we're only going to take out the pieces we need. So again, we're going to create another work directory like /app, and then we are going to take only the parts we need. So we need the package.json so we can get access to the scripts and we actually know kind of what we need to install. We know we need the ./build because this is what the output was built to. This is the things that we believe is needed to run. And then finally, we actually do need to npm install. And the reason you're going to need to do this is if you rely on any Node modules, which probably you do. But we're going to pass it this -- production flag. And what that's going to allow us to do is only install the dependencies, not the dev dependencies. And in most apps, this will probably save you a few percentage points, a few megabytes in your final image size. Finally, we're going to expose our port 8080. Yours is probably going to be different. And then we're going to tell it that when you run this image, we want you to enter at npm run start. And we can see that start here is just going to export 8080. That's where it wants Node to listen. And then it's going to run Node on this /build folder. Now that's a mouthful, and this is a little bit of code. If you just want to copy and paste it and try it out in your own app, you can do that. I'll have the full source code at this link at the bottom of this slide, and I'll also have that in the description of the video. So this is how I build all of my SvelteKit front ends, and this is all included in Cloud Seed, which is a full stack Dockerized project boilerplate. If you just want to use SvelteKit, that's fine. If you just want to use the F#.NET, that's fine as well. So if you're curious about getting a full app up and running and see kind of how it works together, you can get that out cloudseed.xyz. Now, if it's working for you and you're happy with it, you can leave the video now. But I did have to do a good bit of research and kind of trade-offs of like different ways to create this Dockerfile, and I thought it might be interesting to share some of those questions and some of the answers that I have and why I built it the way I did. Once you can actually understand why mine fits, my purposes, especially for Cloud Seed and building all these projects, but two, to just think about like if your project fits the same requirements or not. This should work great for like 95% of projects, but it might be useful to understand the trade-offs. So the first question and trade-off here is like, why are you doing this multi-stage Dockerfile? So obviously multi-stage is a little bit more complicated. You have to make sure that you're bringing over the right artifacts to every stage. And so it's kind of just extra logic, right? Which is usually bad. So the reason that multi-stage usually exists in Docker is to try and create smaller images. In pretty much any language or technologies that's compiled, and most of the better ones I would argue are compiled, you're going to want different stages because usually the build stage needs a lot more resources and things than the actual run stage. These are things like IntelliSense or types and extra stuff that you want that makes development good, but you don't actually need for running. And so by discarding this stuff, we actually will usually get out a run image that one might be potentially faster, but two is almost definitely going to be smaller. And this is good if you're copying and pasting everywhere, or if you're building at scale and need to like host these artifacts somewhere. So when I was doing this for Cloud Seed and in my projects, when I went from single stage to multi-stage, I was able to shave off about 20 megabytes or about 16% of my total image size, which can really add up. Now to prove to you that most compiled things in Docker containers are also multi-stage, you can check out this one, which has all my code for how I Dockerize F# and .NET, and I'll have a link below in the description if you want to do that. The next big question I kept running into was which release of the Docker image should you use? Normally Docker images have a ton of different image types. Slim, Alpine, regular are common ones, but there's also going to be ones for every different version and stuff. And this just allows you some control over which version of this thing you're actually using and putting into your infrastructure. So typically the Slim and Alpine versions are going to be much smaller than whatever the regular version is. The regular version typically will ship with like an entire OS, and Slim and Alpine try to just do the minimal parts of OS that you actually need to run whatever image you're running. And this is probably best for most things. So when I was, again, doing this with Cloud Seed, the regular image of Node was 409 megabytes. And then when I went to Slim and Alpine, it goes down to 105 and 92 respectively, which is about 75% reduction, which that's like a huge difference, especially if you're hosting this somewhere, even more important than what I was talking about earlier. Now, the real question comes in like, well, when would you want to use Slim versus Alpine? Because you almost never want to use the regular version, the full-sized OS, unless you're doing like a lot of OS kind of specific things, but most things probably don't need that. But Slim and Alpine is an interesting question because I think Alpine is probably most popular for most of these repositories. But interestingly, Alpine also has the most documented performance pitfalls. And from my research of this, the reason is because they actually make some trade-offs themselves in the libraries that they use at the OS level to try and squeeze out the extra, savings on size. But those libraries they use are often not the most optimized. They're often not the most standard ones out there. And so in some ways, if you use them in particular ways, they might have significant drops, like up to 50% and in some cases, especially when running Node. So I have links to all these references for all these performance pitfalls that you can find again in the linked thing. But for me, Slim gives almost as much savings on the storage size as Alpine. So that seems pretty good. And then it doesn't have the documented performance pitfalls because it's using those standard libraries that you get in regular. It's just only using the ones you need for this package. So that's why I chose Slim. But if you really care about storage, maybe Alpine's for you. Okay, why am I using the LTS version versus latest? So LTS is usually long-term support, and typically this is going to be an older version of something. So it's something that, the developers have decided is really stable. They've developed it for a long time, but they're probably not adding as many new features to. Latest is whatever the latest branch of whatever they are working on. And this is going to have the most up-to-date features, but those features aren't going to be as stable. There might be bugs in them. There might be security issues in them. They might just, they just haven't been used as much. So they're just probably not going to be as stable. And most software does this. Most software has an LTS that's a little bit older and will get updated every 2-ish years. And latest will just be whatever the latest thing the developers put out. So the big trade-off here is between stability and whether you need the latest features. For most of my projects, especially with Cloud Seed, where we're not doing anything cutting edge, I want this to work for 95% of projects, and I want this to work well. Stability is gonna win. We're only using parts of these packages that are well used, they're performance tested, everything like that. And if you actually want something from the latest branches, you can always update to use a later version. But typically you don't need them, and LTS always, gets upgraded eventually as well, so you'll get them eventually anyway. So that's why I chose LTS, but if you really want to eke the most out of Node and get the latest features, maybe latest is for you. Now, why did I go through all this work to serve with Node versus Vite Preview? This is an interesting question, and it really often only comes from these newer projects that are being built with SvelteKit or whatever is built on Vite nowadays. And this is because most of the examples that you're going to get probably use Vite Preview for their NPM start. And now, just because this is most common doesn't actually mean it's super good to do. So if you actually look here, I've got a screenshot of the Vite official documentation, and it literally says that Vite Preview is not built for production. But that probably doesn't stop a lot of people from actually running this in production. It didn't stop me for over a year. And honestly, it doesn't really matter. I think we have so many cases in software where we say this thing is not for production, and then we see these unicorn startups who are using Express in production, and it didn't matter. It got them to scale to $1 billion valuation. Does it actually matter? Probably not. That said, if the official decision is not to use it in production, I like to stay away from it, and so that's why we went through this effort to go with Node. Now, I haven't seen much change in my own performance, but my apps usually don't get that much traffic, so we probably wouldn't see it. But one thing that I think probably is different is Vite Preview tends to try to optimize lazily, whereas if you went through all these steps to build an optimized version, Node is really running the most optimized thing we could create at this time. So I would expect it to have some performance improvements, definitely a smaller image size, but whether that matters to you is, depending on your workflow. So that's it. If you found this interesting, if you're still with me, you might be interested in this, where I kind of go into Svelte is better than React and compare the two. I have a link here at the bottom and also have one in the description below. Let me know if you have any questions about any of this stuff, especially around SvelteKit, around Node, around Dockerizing it, building a full stack app, stuff like that. That's what I've been doing recently. That's what I've been doing with Cloud Seed. So yeah, whatever you kind of give me is kind of how I decide what to make next. And finally, this is where you can reach me with any of those questions, and I'll try to answer, as soon as I can. I think that's it. Thanks for watching, and I'll see you in the next one.